Student friends, in yesterday's lecture, we studied the concept of VSB, that is a vestigial sideband, which is used in television communication to reduce the bandwidth from 10 megahertz to 7 megahertz so that one upper sideband is completely passed with the introduction of the sound carrier at 5.5 megahertz and having 0.25 megahertz guard band. Some part of lower sideband which is clipped at 1.25 megahertz. That means almost all DC level frequencies are going to be considered here, and which will save the bandwidth of 3 megahertz by reducing it to 7 megahertz from 10 megahertz. Some part of the lower sideband it is taken, that some part we call it as a vestige. And that's why that bandwidth we can call it as it is a vestigial sideband. We also studied the another type of analog modulation, and that is a frequency modulation, in which we studied that it is a process in which the frequency of high frequency carrier wave is varied in accordance with that of instantaneous amplitude of the signal to be modulated, or the signal to be transmitted, or the signal to be communicated. We analyzed that particular frequency modulation mathematically. We studied its waveforms. We studied how the modulation is going to depend upon its modulation index MF, which is the ratio of frequency deviation upon modulating frequency. As the modulation index changes, the number of sidebands, those changes in the frequency spectrum. Thus we can say, depending upon modulation index, frequency modulation has got infinity sidebands, out of which some of these sidebands having the amplitude 5% of the carrier wave are capable to be used for the purpose of communication. Dear students, that's what we have studied in the yesterday's lecture. Today we are going to consider the comparison between AM and FM. We have studied the amplitude modulation as well as the frequency modulation as the types of analog modulation. Now we are going to compare both the modulation with each other. The first distinguishing point between amplitude modulation and frequency modulation is that amplitude of frequency modulated wave is independent of modulation index, while in amplitude modulation, wave depends upon modulation index. Amplitude of the FM wave is independent of the modulation index. Modulation index has nothing to do with the amplitude in FM modulation, but modulation index is going to do almost all the role in amplitude modulation. That means amplitude of the amplitude modulated wave is going to depend upon modulation index, whereas amplitude of the frequency modulated wave is independent of modulation index. This is the first differentiating point between AM and FM. Second point is, all transmitted power in frequency modulation is useful, but in AM most of the power is in the carrier that doesn't indicate any modulation. As we already studied that, in case of frequency modulation, power remains constant. One can use it for transmission. In AM, 2/3 power is present in the carrier wave, 1/3 power is present in the sideband. Carrier band doesn't contain any modulating signal, but sideband only contains the modulation signal. That's why we can say in FM, almost all power is useful. In AM, only some part of carrier power is useful. In other words, we can say in FM, power remains constant, as amplitude remains constant. In AM, as amplitude changes, power also changes. This is the second distinguishing point. Third one is in FM, noise is decreased than AM. AM communication is a bit noisy than that of FM. FM is less noisy. Clarity in FM is more rather than in AM. That's why we can say in frequency modulation, noise is decreased than in case of amplitude modulation. Next one, by increasing the frequency deviation in frequency modulation, noise is further reduced, but it is not available in AM. You can change the frequency deviation in FM so as to reduce the noise further, but this facility is not available in amplitude modulation. Next one is adjacent channel interference is less in AM than AM due to availability of guard band. In FM, interference of the channel, adjacent channel is less than that of AM. Next one is a large bandwidth of 7 to 15 times that of AM is required in FM. This is the disadvantage of FM. FM needs the large bandwidth than that of AM. For AM, bandwidth required is less. For FM, bandwidth required is more. That is the meaning. Next one. Transmitting and receiving equipments in FM are complex and costly than AM. FM communication is in short costlier than that of AM communication. Next one. In FM, reception is limited to line of sight. Area covered by FM is less than AM. AM is used for long distance communication, but FM is used for short distance communication. So these are the advantages and disadvantages of AM and FM, or we can say distinguishing point between AM and FM, or we can say merits and demerits of AM and FM. Dear students, that's all about the comparison between AM and that of FM. Friends, up till now we have studied the analog communication along with the differentiating points between amplitude modulation and also the frequency modulation. Now we are going to change our track from analog modulation to digital modulation. Whenever digital communication is necessary, in that particular case, analog modulation is not possible to be used. It is replaced by means of a digital modulation. Digital modulation is used for the digital signal to be communicated. Whenever the digital signal is to be communicated, then the digital modulation is used. But whenever analog signal is going to be communicated, then analog communication is used. What do you mean by digital? Digital means the signal is in the form of discrete. The signal is not in the form of continuous variation. The signal is the combination of 0 and 1. If the signal is to be communicated in the form of 0 and 1, then the digital modulation is being used. Here we are considering that information message is available in the form of digital, or even if it is available in the analog, it is going to be converted into digital and then it is used for the digital modulation, and then it is transmitted from one place to the another place. As at the beginning of this particular topic we have studied that there are different types of digital modulation. One is ASK, that is amplitude shift keying. Second one is FSK, that is frequency shift keying. Third one is PCM, that is pulse code modulation. Fourth one is PWM, that is pulse width modulation. Next one is PAM, that is pulse amplitude modulation. Last one is PPM, that is pulse position modulation. We are going to study the concept of all these types of digital modulation. Let me begin with first type of digital modulation whose concept we are going to study, and that is amplitude shift keying. It is abbreviated as ASK. What is happening here? In this case, as the input information changes from 0 and 1, the shift of amplitude, that amplitude of the carrier wave, that takes place. For high input, that is, for if input is 1, amplitude is maximum, and if input is 0, amplitude is 0. That's what we can say. There is shifting of amplitude of carrier wave takes place from maximum to 0. Depends upon whether input is 1 or 0. The higher level signal in digital electronics, it is called as a mark signal. The lower level signal in digital electronics, it is called as a space signal. When the signal changes from mark to space, frequency shift that takes place from maximum to 0. So that's why it is also called as on-off keying. OK means on-off keying. So this is what the meaning of amplitude shift keying. Let us see that concept in detail. In ASK, it is the process in which the carrier wave is switched from one amplitude level to other by binary signal. As the binary signal changes from 1 to 0, amplitude of the carrier wave is going to switch from one level to the another level. How it is? That is, during one state, if the binary signal is 1, that is known as the marks, amplitude of the signal increases the carrier level, but while during the 0 state, that is space, amplitude of the signal reduces the carrier level. This is also known as on-off keying. Carrier is made on when mark signal is at the input, and it is made off when the space signal is at the input. Always digital signal is represented in the form of DC-level square wave pulses. From that point of view, here on period and off period are mentioned. Such a type of modulation is used in wireless telegraphic communication circuit. This transmission is ICW transmission. If the carrier wave is EC, that is EC sine of omega ct, we are well known about this equation now. Then modulated signal using OK means amplitude shift keying will be Si of t is equal to mu of t into EC sine of omega t. This is the modulated signal. For mu of t is equal to 1, if mu of t is 1, that is a mark signal, and mu of t is equal to 0 for space signal. If mu of t is equal to 1, then SIT is equal to EC sine of omega ct. Its amplitude is as like that of the carrier wave. If it is 0, then amplitude of the modulated signal is 0. That is for space signal. By using Fourier transform, same equation we can write it. S of omega is equal to EC upon 2 f of omega c minus omega s plus f of omega c plus omega s. This is a Fourier transform of this equation. Thus, it produces USB and LSB. So, this is LSB, whereas this is EUSB, as it is present in amplitude modulated wave. The bandwidth of such a system is twice the highest frequency of the pulse signal. Bandwidth generated in case of modulated wave of ASK is twice the highest frequency of the input pulse signal. Dear students, this is what the ASK it is represented. Look at here. This is the signal to be transmitted, that is in the form of digital, that is 1010, like that. And this is the carrier wave. And this is the modulated wave. ASK, amplitude shift, or OK modulated wave. For input signal 1, it is as like that of carrier wave. If input is 0, amplitude is 0, no carrier wave is present. Again for 1, carrier wave is existing. For 0, carrier wave is not existing. So amplitude of the carrier wave is shifting from maximum to 0. That's what we can call it as, it is the ASK. The concept is very, very simple. It is used to modulate the digital information in digital transmission system to carry the information in the digital form from transmitter towards the receiver. Let me proceed further to study the concept of FSK, which is the second type of digital modulation. Here also, instead of changing amplitude of the carrier wave, frequency of the carrier wave is shifting. Means it has a two carrier wave and shift in carrier wave frequency that takes place. What happens is, if the signal is 1, it has a maximum carrier frequency. If the signal is 0, it has a minimum carrier frequency. Here frequency that shifts, that's what is called as frequency shift keying, FSK. It employs two different carrier frequencies which are switched on and off alternately by mark and space signal. A mark signal switches on one carrier frequency while other carrier frequency remains off. Under space condition, the first carrier is switched off and second carrier is switched on. Means basically two carrier frequencies or two carrier wave are existing. One is appearing for mark signal, another is appearing for space signal. Where frequency shift that takes place, it is represented here. So for one, the time is maximum, frequency is less. For 0, time is less, frequency is more. Reverse is also true. Only the thing is that there is shift in frequency that is existing. This type of modulation is used in signaling the speed up to 1200 bauds with the carrier frequency 1300 Hz and 2100 Hz, that is for mark and space. It is frequency modulation with center frequency 1700 Hz and frequency deviation plus or minus 400. If you add plus 400, you will get 2100. If you subtract 400 from 1700, you will get 1300 Hz. So that is called as a frequency deviation. The bandwidth of FSK signal is twice the highest frequency in modulating signal. It is true for FSK as well as ASK. For higher signaling rate, it is not used because it requires a large bandwidth, which results excessive noise. It is used in frequency modulation, voice frequency transmission. FM voice frequency communication utilizes the frequency shift digital modulation technique. Dear students, that's all about two concepts of the digital modulation. One is ASK and FSK we have studied, along with the comparison between AM and that of FM. That's all about today's lecture. Next time we'll study some another type of digital modulation